When studying geometry, we use undefined terms, assumptions known as postulates or axioms, definitions, and theorems and other conclusions. Our two major undefined terms that we've used so far are point and line, and we've used those two undefined terms to define numerous other terms. Postulates or axioms are statements assumed to be true without proof. We haven't introduced any postulates or axioms yet. The words are very closely related. Some textbooks use postulates, some use axioms. I will use postulates for this series of lessons. So from now on, our statements assumed to be true without proof will be known as postulates. The first one that I'll introduce in a few lessons is this example. Any segment or angle is congruent to itself. That's known as the reflexive property, and it has a lot of similarities to the reflexive property of equality that you may already know from a previous algebra course, which simply states that a number is equal to itself. We have looked at two theorems so far. Theorem 1, if two angles are right angles, then they are congruent. And Theorem 2, if two angles are straight angles, then they are congruent. And of course, a theorem can be proved, and in a previous lesson we showed proofs of each one of these theorems. Among the terms already defined in this set of lessons are line segment, ray, angle, congruent, acute angle, right angle, obtuse angle, straight angle, polygon, triangle, adjacent angles, union, intersection, collinear, theorem, midpoint, trisection points, angle bisector, angle trisectors, and postulate. And now yet another definition as we define the word definition. A definition states the meaning of a term or idea. Definitions can be written as conditional statements. Conditional statements are written in the form if P, then Q, where P and Q are declarative statements. The if part, P, of a statement is called the hypothesis, and the then part, Q, is called the conclusion. Another way to write if P, then Q is shown, sometimes it's read P gives Q. Well, let's look at our definition of a right angle. A right angle is an angle with a measure of 90 degrees. And since all definitions can be written as if-then statements, let's write this definition as an if-then statement. Here's what we get. If an angle is a right angle, then it has a measure of 90 degrees. And we already know that definitions are reversible, and that's called the converse. If an angle has a measure of 90 degrees, then it is a right angle. So, if Q then P is the converse of if P then Q. The converses of all definitions are true statements. The converses of theorems and postulates are not always true. Theorem 1, it's an if-then statement, but the converse is false. So Theorem 1 says if two angles are right angles, then they are congruent. The converse would be if two angles are congruent, then they are right angles. But Theorem 1 isn't a definition. While it's true that if two angles are right angles, they're congruent, there are many examples of congruent angles which are not right angles. So Theorem 1 is true. The converse of Theorem 1 is false. This theorem is not reversible. When studying geometry, we use undefined terms, definitions, postulates, and theorems. Definitions can be written as conditional statements, often in this form read if P, then Q. The converses if Q, then P of all definitions are true. Not all converses of postulates and theorems are true.